To obtain a PE license, it's important to understand the experience requirements set forth by the National Council of Examiners for Engineering and Surveying, or NCs. For the electrical and computer power exam, NCs typically requires 4 years of progressive experience in your discipline under the direct supervision of a licensed professional engineer, or P. The experience you gain at a design-build contractor can be valuable, but if you are not working under the direct supervision of a P, it may not fulfill the NC's experience requirement. Consider your long-term career goals. Do you want to continue working in design-build, or would you prefer a more traditional engineering role? There are a couple of options to consider. Firstly, continue working with the design-build contractor. This path offers several advantages, including gaining valuable real-world experience in electrical design and construction. It can also help you develop strong practical skills that are highly sought after in the industry. However, there are also potential drawbacks. This path may not fulfill the NC's experience requirement for direct supervision under PE. Additionally, you may have limited opportunities for professional development and mentorship. Secondly, seek employment with an engineering firm. This option offers the advantage of working directly under a PE, which is required to gain the necessary experience for the PE exam. You will also have access to professional development programs and mentorship opportunities, and you can enhance your understanding of design theory and best practices. However, this path may require a career shift away from design-build, and competition for entry-level engineering positions can be high. If your primary goal is to obtain your PE license, pursuing the second option of working at an engineering firm under a licensed PE might be the most direct path. While real-world experience is valuable, it is crucial to fulfill the NC's experience requirement. Consider researching engineering firms that specialize in electrical design and build, and exploring job opportunities that offer direct supervision under a licensed PE. Here are some additional tips. Firstly, reach out to local PE chapters or professional organizations for networking and mentorship opportunities. Secondly, consider pursuing continuing education courses or training programs to supplement your practical experience. Thirdly, seek guidance from experienced engineers in your field. Focusing on electrical systems design, it's beneficial to deepen your knowledge of relevant standards and codes such as the National Electrical Code, or NEC, which is a widely adopted standard for safe electrical installations. Familiarize yourself with key articles like NEC Article 210. For branch circuits, NEC Article 220. For calculations, and NEC Article 250. For grounding and bonding. Understanding these articles will help you design safe and compliant electrical systems. Furthermore, understanding short-circuit calculations is vital for ensuring the safety and reliability of electrical systems. Short-circuit studies help determine the magnitude of fault currents that can occur in a system, allowing engineers to select appropriate protective devices and equipment. The symmetrical components method is commonly used to analyze unbalanced faults, and software tools like SKM Power Tools or ETAP can aid in performing these calculations. Consider the impact of harmonics on electrical systems. Harmonics are sinusoidal voltages or currents with frequencies that are integer multiples of the fundamental frequency, typically 60 Hz in North America. Nonlinear loads such as variable frequency drives, or VFDs, and electronic devices can generate harmonics, which can cause various problems, including overheating of equipment, increased losses, and malfunction of sensitive electronic devices. To mitigate harmonics, consider using harmonic filters or line reactors. Power factor correction is another important aspect of electrical system design. Power factor is the ratio of real power to apparent power and indicates how effectively electrical power is being used. A low power factor can lead to increased energy costs, voltage drop, and reduced system capacity. Power factor correction involves adding capacitors to the system to offset the inductive reactance of loads, thereby improving the power factor. Variable frequency drives are commonly used to control the speed of motors in industrial applications. VFD offers several advantages, including energy savings, improved process control, and reduced mechanical stress on equipment. However, VFD can also introduce harmonics into the electrical system, as mentioned earlier. When selecting a VFD, consider factors such as the motor horsepower, voltage, current, and the application requirements. Additionally, ensure that the VFD is properly grounded and shielded to minimize electromagnetic interference, or EMI. Grounding and bonding are essential for ensuring electrical safety and preventing electric shock hazards. Grounding provides a low impedance path for fault currents to flow back to the source, allowing protective devices to quickly trip and clear the fault. Bonding involves connecting all metal parts of the electrical system together to create an equipotential plane, minimizing voltage differences and reducing the risk of electric shock. Follow the requirements outlined in NEC Article 250 for grounding and bonding. Lighting design involves selecting appropriate luminaires and lighting controls to provide adequate illumination levels while minimizing energy consumption. Consider factors such as the type of space, the tasks being performed, and the desired ambience when selecting luminaires. Use lighting control systems such as occupancy sensors and dimmers to reduce energy consumption and improve lighting quality. Emergency power systems are critical for maintaining essential services during power outages. Emergency power systems typically consist of generators, transfer switches, and batteries. Generators provide backup power to critical loads such as life safety systems, emergency lighting, and communication equipment. Transfer switches automatically switch the load from the normal power source to the emergency power source when a power outage occurs. Uninterruptible power supplies, or UPSs, provide backup power for sensitive electronic equipment such as computers and servers. UPS typically use batteries to provide power during short-term power outages. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning strikes or other transient events. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. Install SPD at the service entrance and at downstream panels to provide comprehensive surge protection. Electrical panel design involves selecting appropriate circuit breakers, fuses, and other protective devices to protect electrical circuits from overcurrents and short circuits. Consider the load requirements of each circuit when selecting the size of the circuit breakers or fuses. Ensure that the panel is properly grounded and labeled for easy identification of circuits. Cable and conductor selection is based on the ampacity voltage rating and environmental conditions. Ampacity is the maximum current that a conductor can carry without exceeding its temperature rating. The NEC provides tables that list the ampacity of various conductors based on their size, insulation type, and installation method. Select conductors with a voltage rating that is equal to or greater than the system voltage. Consider the environmental conditions such as temperature, moisture, and exposure to chemicals when selecting cables and conductors. Conduit and cable tray systems are used to protect and support electrical cables and conductors. Conduit provides physical protection for cables and conductors, while cable trays provide a support structure for cables. Select conduit and cable tray systems that are appropriate for the environmental conditions and the type of cables being supported. Electrical safety is paramount when working with electrical systems. Always follow safe work practices such as wearing appropriate personal protective equipment, or PPE, and energizing equipment before working on it. Use lockout-tagout procedures to prevent accidental energization of equipment. Ground fault circuit interrupters, or GFCIs, are used to protect personnel from electric shock hazards. GFCIs detect ground faults and quickly trip the circuit, preventing electric shock. Install GFCIs in areas where there is a risk of exposure to water, such as bathrooms, kitchens, and outdoor locations. Arc flash studies are conducted to determine the potential arc flash hazards in an electrical system. Arc flash is a dangerous phenomenon that can occur when a short circuit creates an electric arc, releasing a large amount of energy in the form of heat, light, and pressure. Arc flash studies help engineers determine the appropriate PPE requirements and establish safe working distances. Reviewing overcurrent protection is critical to ensure the safety and reliability of electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level, protecting equipment and personnel from damage and injury. When selecting overcurrent protection devices, it is essential to consider several factors, including the interrupting rating, the time current characteristics, and the coordination with other protective devices in the system. The interrupting rating is the maximum fault current that the device can safely interrupt without failing. The interrupting rating must be greater than the available fault current at the point of installation. Time current characteristics describe the relationship between the current flowing through the device and the time it takes for the device to trip. Different types of overcurrent protection devices have different time current characteristics, allowing for selective coordination to minimize the impact of faults. Selective coordination ensures that only the overcurrent protection device closest to the fault trips, while upstream devices remain operational, minimizing downtime and preventing unnecessary outages. Coordination studies are performed to verify that the overcurrent protection devices in a system are properly coordinated. These studies involve analyzing the time current curves of the devices and ensuring that they are selectively coordinated. Software tools can be used to simplify the process of performing coordination studies. Understanding the different types of electrical drawings is essential for electrical design and construction. Single-line diagrams provide a simplified representation of the electrical system, showing the major components and their interconnections. These diagrams are used for system planning and coordination studies. Panel schedules provide detailed information about the circuit breakers and loads in each electrical panel. These schedules are used for circuit identification and load balancing. Wiring diagrams show the detailed wiring connections between components. These diagrams are used for installation and troubleshooting. Lighting plans show the location of luminaires and lighting controls. These plans are used for lighting design and installation. Understanding transformer connections is crucial for electrical engineers. Transformers are used to step up or step down voltage levels in electrical systems. Different transformer connections, such as delta Y and Y delta, have different characteristics and are used for different applications. The delta Y connection is commonly used for stepping down voltage from a high voltage transmission system to a low voltage distribution system. The Y delta connection is commonly used for stepping up voltage from a low voltage generation system to a high voltage transmission system. Understanding motor control circuits is essential for controlling motors in industrial applications. Motor control circuits use various components such as contactors, relays, and timers to start, stop, and control motors. Different types of motor starters, such as across-the-line starters and reduced voltage starters, are used for different applications. Across-the-line starters provide full voltage to the motor at startup, while reduced voltage starters reduce the voltage at startup to limit the inrush current. Power quality is an important consideration in electrical system design. Power quality refers to the characteristics of the voltage and current in an electrical system. Poor power quality can lead to equipment malfunction, increased energy costs, and reduced system reliability. Common power quality problems include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Mitigation techniques such as surge suppressors, harmonic filters, and voltage regulators can be used to improve power quality. Understanding the NEC is crucial for electrical engineers and designers. The NEC is a widely adopted standard for safe electrical installations. The NEC provides requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. It is essential to stay up to date with the latest edition of the NEC and to understand its requirements. NEC Article 90 provides the purpose and scope of the NEC. NEC Article 100 defines the terms used in the NEC. NEC Article 210 covers branch circuits. NEC Article 215 covers feeders. NEC Article 220 covers branch circuit, feeder, and service calculations. NEC Article 230. Covers services. NEC Article 250. Covers grounding and bonding. NEC Article 300. Covers general requirements for wiring methods and materials. NEC Article 310. Covers conductors for general wiring. NEC Article 400. Covers flexible cords and cables. NEC Article 430. Covers motors, motor circuits, and controllers. NEC Article 440. Covers air conditioning and refrigeration equipment. NEC Article 450. Covers transformers. NEC Article 500 through 516. Covers hazardous classified locations. NEC Article 600. Covers electric signs and outline lighting. NEC Article 625. Covers electric vehicle charging systems. NEC Article 680. Covers swimming pools, fountains, and similar installations. NEC Article 690. Covers solar photovoltaic systems. When designing electrical systems, it is important to consider sustainability and energy efficiency. Use energy-efficient lighting, such as LED lighting, to reduce energy consumption. Use occupancy sensors and dimmers to control lighting. Use high-efficiency motors and drives. Use power factor correction to improve power factor. Use renewable energy sources, such as solar photovoltaic systems. Design electrical systems to minimize energy losses. Commissioning is the process of verifying that an electrical system is installed and operating according to the design specifications. Commissioning involves testing and documenting the performance of the system. Commissioning helps to ensure that the system is safe, reliable, and energy efficient. Electrical safety audits are conducted to identify potential electrical hazards and to ensure compliance with safety regulations. The electrical safety audits involve inspecting the electrical system and identifying any deficiencies. The audit report provides recommendations for correcting the deficiencies and improving electrical safety. When working on electrical projects, it is important to manage the project effectively. Develop a detailed project plan. Communicate effectively with the project team. Manage the project budget and schedule. Use project management software to track progress. Conduct regular project meetings. Close out the project properly. Following these guidelines will help you to gain valuable experience, expand your knowledge, and advance your career in electrical engineering. Remember that the specific requirements for licensure and career paths may vary depending on your location. Consulting with experienced engineers and professional organizations is always a good idea. Good luck with your PE exam preparation and your career endeavors.